Let's look at integrating factors to reduce the differential equation to the exact form and how to figure out these factors. So there are certain rules kind of thing which will help you in figuring out the integrating factors. Let's look at each one of these. If m and n are homogeneous functions of the same degree and mx plus ny is not equal to 0, then 1 by mx plus ny is an IF, integrating factor. For mdx plus ndy is equal to 0 equation. Okay, second one, if 1 by n times dou m by dou y minus dou n by dou x is a function of only x, that is f of x, or a constant, let's say k, then e to the power of integral of f of x dx or e to the power of integral of k dx is an IF, integrating factor. For the equation mdx plus ndy is equal to 0. Okay, second one, if 1 by n times dou m by dou y minus dou n by dou x is a function of only x, that is, let's say f of x, or a constant, let's say k, then e to the power of integral of f of x dx or e to the power of integral of k dx is an integrating factor for mdx plus ndy equal to 0. Third one, if 1 by m, the previous one was 1 by n, times dou n by dou x minus dou m by dou y is a function of only y, that is, let's say g of y, or a constant, let's say k, then e to the power of integral of g of y dy or e to the power of, in case of a constant, integral of k dy is an integrating factor for the equation mdx plus ndy equal to 0. Fourth one, if the equation is of the form f of x comma y, f1 of x comma y times y dx plus f2 of x comma y x dy equal to 0, with m is equal to y times, and this is quite straightforward, x comma y, and n is equal to f2 of x comma y x, and mx minus ny is not equal to 0, then the integrating factor would be 1 by mx minus ny. So let's see how to use these integrating factors. So let's look at xy dx minus x square plus 2y square dy is equal to 0. Now here m would be equal to xy, n would be equal to minus x square plus 2y square. Okay, now x square square, and here 1 plus 1 2. So homogeneous of same degree. So let's see, based on the first rule, mx plus ny means what? Take m, multiply it with x, you get what? Xy times x is x square y plus, so here minus is there, so minus. Now you have to multiply with y, so x square plus 2y square times y, x square y minus x square y minus 2y cube. So these two get cancelled and you're left with minus 2y cube. mx plus ny as per the rule is not equal to 0. So therefore the integrating factor would be equal to 1 by mx plus ny is equal to minus 1 by 2y cube. Okay, so let's multiply this with to the equation. So xy dx minus x square plus 2y square dy equal to 0 times minus 1 by 2y cube. Okay, let's multiply minus xy dx by 2y cube. Minus times minus plus. So x square dy by 2y cube plus 2y square by 2y cube dy is equal to 0. 2 gets cancelled, y square gets cancelled. Here y gets cancelled. So what we are left with is minus x dx by 2y square plus x square dy by 2y cube plus, here we have 1 by y dy. Now comes the challenging part. How to do the grouping? Now we know the integral of this, right? Straightforward, log y. So let's bring it to the front. 1 by y dy plus x square dy by 2y cube minus x dx by 2y square equal to 0. Now let's look at these two as a separate this one. Okay, so x square dy by 2y cube minus x dx by 2y square equal to 0. Okay, first of all we have to make sure that it is in the m dx plus n dy form. Yes, so here dx is here, so let's bring it to the front. X dx by 2y square minus x square dy by 2y square, no, 2y cube equal to 0. Okay, so this m becomes x by 2y square, n becomes minus x square by 2y cube. Now straightforward, integral of m dx plus integral of n dy without terms with x equal to c, right? So now m dx, here y constant, remember? So this would be x square by 2 times 2y square plus, here there is nothing, so 0 is equal to c, because n contains x, so that's why we don't have any terms without x. Okay, so which means the solution for this part of the equation is x square by 4y square. So now what we'll do is we'll go back to our main problem. Now we can write this as a differential of log y, and this we changed here, we rearranged it and we took out minus out, so minus differential of x square by 4y square is equal to 0. Now we just integrate, so integration and differential get cancelled. So our solution is log y minus x square by 4y square is equal to c. Next problem, let's say we have y times 8x minus 9y dx plus 2x times x minus 3y dy is equal to 0. Now here m is y times 8x minus 9y and n is equal to 2x times x minus 3y. Okay, now let's look at rules. Now here you notice x and y times this is that, so let's look at dou m by dou y minus dou n by dou x. Now dou m by dou y, so we have to integrate this with respect to y. So 8x minus 18y, and then minus, we have to integrate this with respect to x. So this is 2x square, so that becomes 4x minus 6xy, so this becomes 6y. 8x minus 4x minus 18y plus 6y, 4x minus 12y, and if we want we can take common out, 4x minus 3y. Okay, now what do we do? 1 by n times dou m by dou y minus dou n by dou x would be equal to what? 1 by n. N is what? N is 2x. 1 by 2x minus 3y. Now 2 times 2x times x minus 3y times dou m by dou y minus dou n by dou x is 4 times x minus 3y. So x minus 3y gets cancelled. 2 2's 4. So we are left with 2 by x. Now see here, this is a function of x only. That means y has disappeared. So as per our rule, integrating factor would be e to the power of integral of 2 by x dx, right? So when you integrate the exponent, what do you get? You get 2 log x. This can be written as e to the power of log of x square. E and log get cancelled out and you're left with x square. So the integrating factor is x square. Now let's go back to our original equation. Y times 8x minus 9y dx plus 2x times x minus 3y dy equal to 0. To this we multiply it by x square, our integrating factor. So we get x square y 8x minus 9y dx plus 2x cube times x minus 3y dy equal to 0. Let's expand it off. X square, no, 8x cube y dx minus 9x square y square dx plus 2x to the power of 4 dy minus 3 times 2, 6x cube y dy equal to 0. Now you look at this and try to recognize some pattern. If you notice here, if you differentiate this, you will get what? 8x cube. Yes. So you have 8x cube here, right? So something familiar looks. Okay, so let's group them together. 8x cube y dx plus 2x to the power of 4 dy minus 9x square y square dx. Both of them have minus, so group them together and take minus out. So plus 6x cube y dy equal to 0. Okay, now can we solve this? Yes, this is nothing but the differential of 2x4y. Just try it out. Apply the product rule. So x4 as it is, 2x4 as it is dy. So this one. And if you keep y, then this becomes 8x cube. So this one. Okay. And this would be differential of 3y square x cube equal to 0. Just try it out. Keep y constant. So then what happens? 9x square y square dx. And if you keep y constant, you get, no, if you keep x constant now, it becomes 6y x cube. Okay. Now integral differential gets cancelled out. So what you're left with is 2x4y minus 3y square x cube equal to 0. And a little bit of simplification. X cube is common and a single y is common. So x2xy minus, no, y is already there, out, taken out. So 2x minus 3y equal to 0. So that is equal to C. This should again be C. Don't forget the integrating constant. There are 4 rules. Just check out, is it homogeneous function? M and N, are they homogeneous of the same degree? Then straightforward, your integrating factor would be 1 by mx plus ny. Take m, multiply it with x. Take n and multiply it with y. Add them together and take its reciprocal. That will be your integrating factor. If it is not homogeneous, then just try to solve this and figure out. If it is a function, if it gives you a function of only x, then your integrating factor will be this. If when you evaluate this, you get a function of only y, then your integrating factor would be this. Now, if the equation is of this form, one particular function times y dx, another function x dy, then try out this mx minus ny. If it is not equal to 0, then integrating factor would be this. Okay, just need to practice a lot. Okay, bye for now.